Okay, let me make sure I get my right screen shared. So, can someone confirm that you can see the just the opening slide there, not the
I see it.
presentation side of this? Great, thank you. Um, so we're going to talk about dimensional modeling. Just a little bit about myself. I'm currently a principal consultant with Sirius, and I've been doing data. I think of myself as just like a data munger since 1997. Started working on the BI platform in 2001. Have been worked with other um, vendors off and on, and there's some really exciting new technologies coming out now. You've had a chance to both work with clients and also do some instructing and presenting. I really think these types of professional groups are really important. Was lucky to be able to help with the TDWI up in Seattle, and I've got to modify this slide. I need to put member of the Salt Lake City SQL Server user group on it. I didn't think about that. And enjoy being in the outdoors and doing some community service. So you've maybe heard of dimensional modeling or star schema, so I thought let's have a little bit of fun with thinking about the stars, and copied a few things here. Unfortunately, when we build out dimensional models and star schemas, we probably will be responsible for our actions. And I think if dimensional modeling can really help change your life and analysis. And let's see, understanding so simple a thing as a star. Dimensional modeling, it's part science, but there's a whole lot of art in it. And, they help us visualize our data. And anyway, it was fun to play around with that a little bit. So, we'll talk a little bit about organizing our data in a dimensional model, which will make it easier for our users to analyze data. And we model the data in a fashion that makes queries run faster. We can combine data from multiple data sources. And we'll touch on this a little bit more, but I've seen lots of cases where organizations just get overwhelmed with the number of views and stored procedures and tables that they create for reporting, and hopefully using a dimensional model can relieve you of having all those tables and views. So one of the first things to think about is the typical analytical question. So, oops, I've got this one twice here, but you see questions like, what are my sales by product, by salesperson, by month? What's our lease conversion? Just working with a client that we're analyzing the security scans of their cloud accounts. And so what are their number of alerts by severity over time? So all these analytical questions, they almost always fall into this pattern of what is fact by attribute by attribute by attribute. And that is asking questions in a dimensional format. I've got this slide out of place, so I'm going to come back to it. So let's talk about just kind of the basics of dimensional modeling. And that is you're going to have dimension tables and fact tables. And at the very simplest level, a dimension table is a group of attributes. They're related to one another, and they describe one of the aspects or dimensions of your organization's activities. In a dimension table, you'll most likely have a business key, that uniquely identifies a row, so it might be a customer ID. Sometimes it may be a combination of columns, but it's if a business user were to, say, look at the business application, SAP or Salesforce, and wanted to uniquely identify something in there, they'd be doing it by the attributes, and that's the business key. And then these related attributes, they are descriptors of our business key. And then we're going to have a numeric identifier called a dimension key. That'll be our primary key of our dimension table and allows us to uniquely identify a dimension record. And then we're going to have a fact table, and it's a very most strict definition of a fact table. It's going to be the keys from the dimension tables and then measures that are the numeric values associated with that. So a group of related measures. And what enables you to have one fact table versus another is if the measures, the numeric values, are described by the same set of dimensions. Then technically you could put them in the same table, but if they have different dimensions, you'll have to put them in a different table. Let's go back just so we don't skip this slide. So one of the things that I've seen is how people present data to their analysts and report consumers. And there's a couple of ways that they do that. One is, create a bunch of flat tables from source data or a stored procedure or a view, and let the data analyst consume that. Or maybe they're presenting the data in third normal form. In fact, it's still more common than what I'd like to see, where analysts and report writers are querying the business, the database that's the back end for the business system. And so first of all, that data is really not optimized for reporting. It's optimized for inserts, updates, and deletes, and for singleton queries. And then the second thing is you certainly don't want somebody running a summarize past sales for the last 5 years by month against your transaction system, putting that great big workload on it. There's also a modeling methodology called Data Vault, which is great for keeping track of the state of your data through time, but again, it's not all that convenient to report on. And then another thing that's really common that causes a lot of work and in terms of maintenance and can end up with a lot of inconsistency is, I've got a new report, let's create a new table or a new view or a stored procedure, where there's as many objects in the analytical database as there are reports, or maybe a table for every 2 or 3 reports. But a lot of maintenance here, and then if you have multiple tables but maybe they're related or similar data, those are going to get inconsistent, and this is just a real struggle to keep accurate and to maintain. And then of course chaos. You may have data in a database and some Excel files and flat files, just data here, there, and everywhere, and the analysts have to a lot of tribal knowledge about here's where you go in order to refresh this report or to get data on this subject. So we want our dimensional modeling to help us solve those issues as well. So here's a typical example of a dimensional model. So I don't know if I've ever created a dimensional model that hasn't had a date dimension. That's ubiquitous. This is from a, a pharmacy, specialty pharmacy that we did some work with, and so they, had a fact table that contained all their prescriptions, and then a doctor dimension, a date, and a drug dimension, store and patient dimensions. So that's a very simple dimensional model. And of course, they're also referred to as star schemas, and it's just the arrangement that somebody made and said, oh, that looks like a star. So dimensional model or star schema are referring to the same thing. Some other things that you may hear about are like snowflake dimensions or a snowflake model. And that's where you break out, your dimensions by levels of aggregation. So I may break out a month table, and I didn't put it here, but you often see like the date, the month, the quarter, semester, year at times broken out. Or here we've broken out our specialty from the doctor table, different attributes for each dimension. And so that's a snowflake. I would still call this a dimensional model as well, in that it's based around the dimensions of the business. We've just broken out some of the aggregation levels. One reason why you may want to do snowflaking in your dimensional model is to break out those aggregation levels, is that you may have fact tables that have different levels of detail. And so while your prescriptions may be at the date level and the patient and the doctor, your sales quota, you may just know we set our quotas by a month and for the drug in the state only. And so in order to be able to join your dimensions to multiple fact tables or different subject areas, you may break out snowflake tables. Here's an example of a dimensional model where I've also added in the attributes. So you can see we've got our different dimensions here, and every dimension needs to have a key. And in general, the best practice is that's a numeric key. And then you add the attributes for that dimension. And you can see in these dimensions, I've also included the key for the snowflake table. And one of the things we'll talk about is when we do dimensional modeling, we're not worried about redundancy. So if I were to think about a third normal form model where I have dim date and then I have dim month, in my date dimension I'd have a month key, and then month, quarter, year, these attributes would be in my dim month table. They're redundant here in the date table. But in terms of being able to have queries that perform more quickly and to simplify the queries that I'd have to write, if my fact table is at the date level of granularity, then I can join to my date dimension and I can do my group by month or quarter or year without having to join out to the dim month table. So I will tend, even though I snowflake, I'll tend to take the attributes that are in that snowflake table and bring them down into the child table just to make query more efficient and easy if I'm operating at this level. And sure, I'm going to have, in this date table, I've got all this extra data in here. But in one sense, the size of dimension tables in general, again, art versus science, don't really matter because, this date dimension, I think I've seen ones where we've done 50 years. You could even think of doing 100 years if you had that much history, like a birth dates or planning off into the future. But even if, so if we had 100, you'll have to check my math. If you had 100 years in this date dimension table, that would be 36,000 rows. So that would be nothing compared to a fact table that might have billions of rows. So the size of your dimension tables typically are inconsequential compared to the size of your fact tables. Let's see. So I have my different dimension tables, and again, let's think about doctor. A unique numeric key that identifies the doctor, and then attributes that describe or provide additional information about whatever the dimension key is. And these can be texts and date. You could have numeric values in here, and you need to be careful if it's something that's additive or non-additive. But all of these attributes define the key. So this is just the same as, the primary key rules. The key, nothing but the key, that type of thing. Everything defines the key. So another, and we're starting to launch off a little bit into one of the advanced topics, is having bridge tables. And this is when you have many-to-many relationships, and they are always a challenge. Here's a couple of examples, and again with our pharmacy example, I may want to know what are the sales of drugs based on the diagnosis that that drug is supposed to treat. And a particular drug may have approved for multiple uses, and so just because I know what the drug is, I may not know what the diagnosis is. But I could go out and get some reference data that says this drug is used for these particular diagnoses, and I could even have cases where the drug is used for what it's approved for, and then they have this thing called off-label uses where a physician is prescribing a drug for a diagnosis that's not approved. And so in this table, I'm resolving that many-to-many relationships. One drug may work for multiple diagnoses, and a diagnosis may have multiple drugs that are prescribed. And then I can join that over here to my diagnoses. And that allows me to resolve the many-to-many relationships. One thing that you may see in this bridge table is some attributes of the relationship itself. So for example, somebody may have gone out and done a survey and figured out that for this particular drug, 30% of the time it's for this diagnosis, and 50% of the time it's for diagnosis B, and 20% of the time it's for something else. We'd want that weight to add up to 1. And then when you look at, say, your count of prescriptions by diagnosis, you may decide to apply this weight so that you don't double count your number of prescriptions. And that, again, is you're in the land of estimates instead of hard facts. Here's another example that we worked on where we were looking at auto sales, and when you buy a car, they often have packages, like they'll have the sport package or the off-road package, and in a package, some components like the sound system or the type of transmission or differential or different body styles, etc., may be in multiple packages. And a package usually contains multiple components. So you end up with that many-to-many relationship between packages and components. We store that here in our bridge table. And then, the component price, the amount, if you were to take the whole price of the package, the radio or sound system may have a different contribution to one package than it does to another. And so here you could either have I shouldn't click on that, either a weight or a dollar amount that allows you to, when you sum up across all these components, you don't end up with more sales amount than the total sales amount here. So within your bridge tables, you can include weights to use to avoid double counting. And another nice thing is a lot of the semantic layers like analysis services or Power BI will have the ability to avoid this double counting. So you can do RX count by diagnosis, and it will count 100% of this for each diagnosis, but then when you do the total, it'll only total up from this table. So in your report, it might show, if you were to manually sum the number of prescriptions per diagnosis, it's greater than the total number of prescriptions, but in your little table in Power BI down at the bottom, that total amount is the actual total amount. It knows there's a many-to-many relationship there and compensates for it. So in terms of designing a model, there's a process that you need to go through. And the first thing is dimensional modeling is all about the business. And so you have to decide which business process you want to model. And these business processes, they're typically either an event or a state of the world. And for me, it's really helpful to think of a fact table as representing an event. It's a sale that was made. It was a diagnosis that was made. It was an alert in a system monitoring your security. Somebody sold a dump truck. There are other business processes where it's a state. So, for example, at the end of the month, you close the books, and here's the financial state with the all of your accounts and what's the balance in each account, and you may take a snapshot of that state of your business every month. But you're looking at the events or the state of the business. And then the next thing you have to do is declare the grain. And in dimensional modeling, we use this term a lot, the granularity. And that's the level of detail. So I'm going to model a business process, and it could be just my point of sales transactions. And I could decide that I want that at the lowest level of detail. So I'm going to track the second that the transaction occurred. I'm going to go down to the UPC level, who was running the cash register, what store, all those different types of things. Or I may decide, I don't really need all that detail. And so I'm just going to look at daily sales of products by store. And the other thing is the descriptors or the dimensions. Do I want to, have this at the store level or maybe just the district level, day or month, salesperson, or maybe just the sales org? So you want to declare that granularity, and then what are you going to measure? The sales in dollar amount, am I going to measure the number of units sold? If I have cases of goods, am I going to measure the case, or am I going to measure the units in the case? In our prescription example, am I going to measure a prescription or the number of pills in the bottle? And that's an interesting thing to think about is when I am thinking about this measures, I may have to think about how am I going to deal with things that are measured in different units. So in the pharmacy, some things are pills, other ones are liquid, and I may have to figure out how do I converge that. I'm going to just do it by dose. Declaring a grain, it actually implies these things as well. So this is more of just converting what we're talking about in business terms to our model. And so we identify our dimensions and we identify our facts. One thing when we're talking about granularity is that when we create a fact table, every fact in there needs to be the same grain. So I don't, one common thing to see is daily data in a fact table, and then there's a row for the month where they've summed up all the day data for the month. And we really don't want to do that. That's something that either, if we decide we want to improve report performance by pre-aggregating some of the data, we may create a fact table at the lowest level of detail and then an aggregate table that contains summary data. We don't want to put those summary records in the same fact table that we put the lowest level of detail. Another important thing about having the same grain is sometimes we'll have what we call a missing or unknown member. So for example, we may not know the address of a customer. And so we don't want to say, well, I need all the same dimensions and the same level of detail for everybody. Address is important for my analysis, but I don't have it for this guy. What you do there is you create what's called an unknown member in each dimension. So when you're populating your fact table with all of the dimension keys, be prepared to throw in a unknown member for each dimension so that you can go ahead and represent all the dimensions. It almost feels like it's cheating, but it's an important thing to do so that when you join out to all your dimensions, you can do inner joins and know that every fact is going to find a dimension key in every table that it belongs to. And so I'm going to just kind of brainstorm a little bit. That's not the right word, but anyway, one of the things about unknown members is you can do that at a more simple or a more complex way of doing that. And I have seen that handling unknown dimension members in the simple manner tends to be more successful, and the more complex way of handling unknown members is it could be when you go look at your source of your facts that the information for a dimension is missing. So for example, my customer doesn't have an address or doesn't have a zip code. And so what we could say is, okay, that's unknown, or we could say that's missing. And then another possibility is, let's say I've got this sale and the product listed on the sale is not in my catalog of products. So I've got a value there. It's not missing, but it's unknown. And so that's two possible unknown members. Either it's missing or it's unknown. You could say it's invalid. And there's a couple other categories of unknown dimension members. And I have had some cases where our analysts really wanted to know, is this not here because it was missing in the source, or was it invalid? And so we did that. We had different values for different types of unknown dimension members. And then sometimes we would do a lookup where, and I'm just making this up off the top of my head, but let's suppose that I have my product catalog, and then in a different table, I've got the, excuse me, the prices. And so I could be combining multiple tables, and it could be that in one table, what I need is missing, in a different table, it's invalid. So now what do I put in my unknown dimension member on the fact table? Do I put that it's missing or it's invalid because my source data had both? So anyway, be ready to handle unknown dimension members, and simplicity usually works better, although I can see why someone would want to know, is it invalid versus truly missing. So the next thing, and this is a tool, and I'll provide a sample of this, is using a bus matrix or a fact qualifier matrix. And what you do here is you take the different dimensions or attributes of your business. So in our pharmacy example, we have date, doctors, we've seen those before. And I have different business processes. So I've got the, one of the things that was important for a pharmacy is some of the drugs, when they sold them, they could apply back to the manufacturer for rebates or discounts, and that adjusted their prices. They, projections or forecasts, and then of course just the sale of prescriptions themselves. And so I take the different business processes or subject areas. These are what are going to become our fact tables. And I flag what dimension is applicable. So for every fact table has a date, but for doctors and drugs and patients, there was only, those were only available from our pharmacy records. And then when we did prescription or projections, we had a store. I'm not sure why. Maybe the stores applied for the discounts, but we had stores for these things. So not every dimension is applicable for every business process, but you can flag at a high level, this business process uses these dimensions. And as far as I know, Ralph Kimball was the kind of originator of the data warehouse bus matrix, and he actually put dimensions on columns and the business processes on rows. I've just found from my experience, I like to do it the other way. Either way works fine, but this may look a little different than what you've commonly seen it. And then the next thing I like to do is drill down. So, and we'll look at an example here. In fact, why don't we do that? Let's go ahead and look at the example. And I need a second just to make sure I can bring that up. Okay,
And
great.
while you're bringing that up, I'm going to interrupt you and say we do have a couple comments. John Craig is saying the way we handle missing data in our fact tables is to use a zero key in the fact tables key, and each dimension has a zero keyed row that contains like nothing to see here values such as NA or something like that for a name or a description.
Yeah, that's exactly it. And we commonly use 0 or -1 for our unknown dimension. And those cases where someone wanted like invalid versus missing, we'd have -1 and -2. But that's exactly right. And it's interesting because in those unknown dimension members themselves, it can be a little bit tricky on how you populate the various columns. We typically like to have the columns in our dimension tables all be not null, so there's a value in there. For strings, it's easy to put in a NA or not applicable, something like that, or missing. For dates, and again, here's where we have art, you may need to have a missing date. Often we just use the minimum date that the data base will support. Just the main thing is you have a date that is so different from what would be expected that it's obvious to your end users. And another thing that happens there is sometimes you may need like a minimum and a maximum date that represents, this is unknown start date versus unknown end date. And then your users, when they query, they may need to know, do I want to include dimension records that have an unknown start date or an unknown some kind of minimum date, or do I want to exclude those? And similarly for maximum unknown or missing dates. But right, that's exactly the way we handle that. I'll put this example out in, I've got a share that I'll put this information out in. And so the next level down in my data warehouse bus matrix tool is then I can then put in my attributes, and I can flag the different measures. I also put calculations in here. So these might be calculations that I'm putting in either like a business objects universe or in Power BI. And I can also expand my measures. Let's go ahead and here. So I then flag each intersection so when I'm looking at a store, or I'm sorry, when I'm looking at a prescription, all of these values, I can find a store related to them. Let's go ahead and just quickly kind of expand these. Here, patients, they're not related to any of the discounts or projections, but for the RX. And then in terms of my calculations, let's expand those as well. Excuse me. I can see that some of my calculations I can analyze by patient and other ones I can't. I'll just go ahead and expand these again. And the date dimension is, here's a place where the date as a whole applies to discounts and projections and prescriptions, but different attributes in the dimension may not apply to all my different business processes or all my different fact tables. And so here I can document that. Another thing that can happen is our dimensions can play roles. So for example, date is just a general, but for my prescriptions, I'll have an order date and a dispense date. I don't want to create multiple dimension tables for every role that a dimension might play. What I would do here is in my RX fact table have a column called order date key and one called dispense date key, and then map those columns to the date key for those different dates. And I can see that in my forecasts and discounts, the date is available, but I don't have order date and dispense date. And so as you go through and fill this out, this can be a very important communication tool between the business team and the technical team. So they are communicating back and forth about what are the expectations for these different fact tables. And then also for your analysts, not so much if somebody's writing SQL or using a kind of traditional reporting tool like reporting services, but when users are browsing an analysis services cube, and I haven't tried this out in Power BI, but I think you may end up with the same thing, is that if they dragging and dropping, and let's say they're looking at discounts and rebates, and they drag in the order date, or if they drag in the date, but they drag in like just the date itself, often what will happen is when you drag in an unrelated attribute, all your numeric data disappears. And users, data consumers can get confused about, here I am trying to look at the date of these rebates and my data all disappears. Well, the bus matrix can help them come in and say, oh, I can't do analysis at that level. So anyway, this is a useful tool to document your requirements, communicate between the business and the technical team, and then something available for your analysts to, to know what type of analysis they can do and what they can't do. I'm going to go on a little bit of a diversion here, and let's talk about the date dimension. Again, probably the most important dimension that you have. You want to build your date dimension from a process that just generates all the dates. So if you are, let's say you've got a source table that's got your sales data, and you just read all the dates out of that sales data and create and load those into your date dimension, some dates will probably be missing. And, if you're a Monday through Friday kind of business, you don't have any of your weekend dates, that'll be okay. But what happens if there's like a weekday that there's no records for that in your sales table? Then all of a sudden that date just is not there, and you run a report, you show all your dates, and Wednesday, November 5th, just doesn't even show up on the report, and it looks like you have sales every day. So one of the interesting things is when you're doing analysis, where there is no data can often be more interesting than where you do have data. And so having a complete date table is important. The other thing that happens is when you create your date dimension, you can add a lot of information about your dates. So, if you pull dates out of a source table and just use those, you're in your report writing, you're going to have to be pulling out the years, and you can create one dimension and do all these different calculations. Is it leap year? You can have both your calendar and your fiscal year. You can do things like flag, is it a weekday or holiday, with the name of the holiday. So anyway, having a good date dimension and adding all this additional information about your dates is a great thing to do, include in your dimensional model. In this bus matrix example, we also track, do like an initial kind of source to target and tracking of where these come from. So I actually, I didn't delete that out of here. I should do that. I want to get rid of the sources, but here you can see the various calculations or examples of what the business users would be expecting, and how do you number your days of the week, where you get the data for your different dimension attributes, and if there's any calculations, additional information there. You can document that in here. I'm going to get rid of this now while I'm thinking about it. Similarly for your measures, what keys are going to be in each fact table, and then what your data lineage is going to be, information to document that there, any type of calculations that you might be creating, and then just some additional comments and a change log. So anyway, I'll put this out with the presentation, and it's available to use as an example. I hope that's helpful. So that's our bus matrix. And how are we doing for time?
I had another question that came in, Scott, so I'm going to jump in
Great.
right now.
Yes.
Aaron is asking, does anyone have a good way to determine which dates are holidays? Easter is always problematic.
I think Excel is a good way. You put that stuff in Excel and read it out of Excel. No, that's a great question, because there are things like that about, where are your holidays? You can get some reference data for that. I think there's probably a calculation for how you calculate Easter, but that's
yeah, Easter
that's
always
pretty
falls
tricky.
on the first Sunday before the equinox on the full moon.
Yeah. So there are some of these holidays.
Not quite. It's the first Sunday after the first full moon, the vernal equinox.
Yeah. Instead of before, say after, yeah. So it's the first Sunday after the first equinox, the first full moon after the first equinox.
You can always build it out for the next 200 years in the table.
That's yeah.
Yeah.
So,
no, I have that already in a table that I use.
The interesting thing about this, it illustrates the point, is it's much better to figure out that logic or find your reference data and put it into your date dimension, as opposed to trying to do that at query time.
It's also important to note that Easter is not always the same in every country.
Yes. And different countries have different holidays. Different companies will observe different holidays. And then, some of the, like Power BI will generate a date dimension. I haven't looked at that in a while. But the way they do fiscal months and fiscal years can vary from one organization to another. So yeah, let's see. Oh, so these tools to help build the bus matrix, or does it have to be created and maintained by hand? I have been doing it by hand, just in an Excel file. I think that some of your data modeling tools may provide as you model out your dimensions, you can, in the modeling tool, include how they're related to your fact tables. Let's see, right, so you could include how they're related to the fact tables in your data modeling tool, and you could include source to target mapping. So some of the more expensive data modeling tools might be useful. I've always wanted to build out the tables and a little app to, theoretically you could work through what are the tables you need in a database and figure out a app to populate and read those tables. All right, so that's our questions here. Let's see, dimension keys. So this is where there's not unanimity in the dimensional modeling world. There are 3 options. I didn't include the third option because you don't want to use it. There's pros and cons to both of these. I typically just want to use a surrogate or a dumb key. And what we mean by dumb key is the primary key for your dimension table, the dimension key, has no meaning except for it's a unique identifier of the record. And correspondingly, you could use like what's the business key? Right, off the bat, you could think of, well, let's just use social security numbers. Everybody's got a unique social security number. And then you find out that no, not everybody's social security number is unique. And, some people are using borrowed social security numbers, or when they fill that information out, they make a mistake, or the person that reads it and enters it in makes a mistake. But you could have, as a basis of a smart key, other things might be your organization's product IDs, different things that the business uses to uniquely identify things. What you want to do in that case is, so some dimension members may require a composite key, multiple columns, so you'll want to concatenate those and then run a hash algorithm on them that turns them into a big int. There is possibility to have a hash collision, but if you're generating 64-bit integers, that likelihood of having a hash collision is really small. We've not seen that ever happen. The other possibility is to just use the business key as is, just that text field. That's not a good idea. It's going to have a negative impact on your query performance. And if you have a composite key, then when people do joins, they have to do joins on multiple columns, which is both inconvenient in writing SQL and bad for performance. So either take the business key that you're absolutely sure is going to be unique and hash it, or just create dumb integers. The benefit of using your business keys is that when you populate your fact table, you don't have to join to the dimension table to get the unique ID, the dumb key. But you can run into problems like, suppose you join data from multiple systems or businesses merge. You may end up with business keys that collide, whereas with surrogate keys, you don't have that issue. Let's see. Slowly changing dimensions. So this is a, again, a art subject, and this is one that I avoid at all costs. And so the only time we do slowly changing dimensions is when they're needed. And there's three ways of doing slowly changing dimensions. One, and this is where the most common example is, suppose a customer moves. So we've had a change in the attribute. What you could do is just replace his old address with the new address. So you just lose your history. The other type 3 is where you have old and new columns. Another example might be marital status, and you could have current marital status and prior marital status, and they would be the same. So you've got your 14-year-old customer, hopefully he's single. So you just put those in both columns, and then when he gets married, you change the current marital status to married, and prior marital status stays single, and you just update those columns. This is a problem in that you can only, how many ever columns you create to hold this status, that's your limit. The most common slowly changing dimension is type 2, and that is you generate a new dimension record. So I've got our 14-year-old customer, and his record says that he's single, and then when he's 27 and gets married, we create a new dimension record and have his marital status as married in the new record, and his prior dimension still shows that he's single. I'll do a little bit more detail here in a second on this. There are type 4, 5, and 6, I think, but I've just never had occasion to use those. You could look those up if you were interested in that. Here is a simple example. So here's where my customer has moved, and I've got an address table. I went out and bought addresses from a reference data supplier, and so in my customer table I just have keys for the address. And John Smith originally, when he became a customer in 2010, lived at address number 1. On the December 31st, 2016, he moved to address 2, and so I have this effective start and end date, and I changed the flag of this record from yes to no when he moved. This is just a matter of convenience. The other way I can find my current records is either look for this maximum date that your database supports, or some people leave this effective end date as null when it's the current dimension member, but I think it's better to put a value in here, because the type of query that you can run is fact sales joined to customer on customer key, where date is between effective start date and effective end date. And if this is null in your query, you're going to have to remember to coalesce your nulls to the end date. So it's better to just put a value in here. Where knowing this history, I thought of a couple of different examples that are just why this might be interesting. One is in healthcare, you could have a question of how has the environment affected the health of my population? And in that case, when you look at the population, And let's say you've got a Superfund, environmentally degraded area. You would want to look at your population based on where they lived. So if somebody back in their history lived next to the landfill, but they currently have moved on to the bench, you don't want to do your analysis based on where they live now. You want to do your analysis based on where they lived at different points in time to catch when they might have lived next to the landfill. The other type of question you might want to ask is, where should I build my dialysis center? And I'm interested in people that have had a diagnosis of kidney failure, but I don't care where they lived at the time the diagnosis occurred. I care about where they live now. And so I may want to see my patients either where they live now or where they lived in the past. Another thing is you may think that purchasing patterns depend on marital status. So married men have very different purchasing patterns than single men. And so what I would want to do is go analyze my sales based on the marital status of the person at the time they made the purchase. Now, once I've found all my individuals, I've got my purchasing patterns based on marital status, and I want to send out promotions, then I want to send that promotion out based on their current address and current marital status. So this slowly changing type dimension enables us to look at data as it is in the past or as in the current. We've been going for about an hour, and I just listed a bunch of additional topics. Andrea, I'll just let you let me know when to stop. And just some additional topics is, where do you implement? If you were to have asked me this question 15 years ago, I would have said your physical data warehouse needs to be a star schema. Now with the compute and storage capabilities that we have, you may not necessarily implement your dimensional model in your physical data layer, but I think you should, whenever you're presenting data to your end users, except for perhaps your data scientists, but just your normal data consumer or analyst, you should present that data to them in a dimensional model. And so you can do that in either like a logical data warehouse or in a semantic layer. So not so cut and dried anymore that you're going to have a physical dimensional data warehouse. Another thing that when we go in and work with customers that have never done dimensional modeling, they've been taught all about third normal form, and you got to get rid of the redundancy out of your data. When you're doing dimensional modeling, don't worry about redundancy. What we're doing is we're specifically modeling our data to improve query performance and to make it more understandable by our end users. And so go ahead and denormalize the data. Have all that redundancy in there. That's going to be okay. How to get started? I think the best way is to look at your current reports and analysis and just look at those reports and print them out, or screenshot that you can annotate, and just like the different columns in the report say, oh, this is month, so that's my date dimension, this is my customer, this is my customer category, those are in the customer. and just look at some of your existing reports and analysis, and that'll help you figure out what data are your data consumers interested in, and how are they, breaking up the data. What are the attributes and dimensions?
We do have a quick question that I want to throw in before you step on.
Sure.
What do you mean by logical data warehouse? Is that like using views on top of the operational data?
That is, well, so that's a great question. So one thing is I would never run reports on top of the operational system itself. That's not what you said. You said operational data. So at a minimum, I'd use like replication or some way to extract out of the operational system into a data repository. You could do a logical data warehouse using views. There are some products. There are logical data warehouse products now. One I've been working with lately is called Denodo, and what these products will do is you can point them at relational data, you can point them at REST APIs, you can point them at text and Excel files, you can point them at Hadoop, all these different JSON data, all these different formats, and the tool will let you either decide to pull the data into a repository or just pass through queries, and the logical data warehouse tools will, behind the scenes, take care of the fact that I'm pulling data from Azure Synapse and Hadoop and an Excel file, and figure out the most economical way to join that data together. And they will allow you to decide if you want to bring that data into a intermediate data store. So you can either do that with views, or you can use a logical data warehouse tool.
And then we had one other one. I see that Pluralsight has a course in dimensional modeling by Chris Smith. What are some sources that you would recommend to learn more?
Oh, so there's some books that are a little bit dated, but by the Ralph Kimball and Kimball Associates. And Ralph has retired now. Some of his, the word is escaping me, but some of the people that worked with him are continuing on in that. But if you Google Ralph Kimball Associates or Kimball Data Warehouse Tips, you can get a lot of information there. And then there's the Data Warehouse Toolkit, and I think there's a dimensional, he's got a dimensional book as well. So if you go out to Amazon and look for books by Ralph Kimball, there's other authors as well. Let's.
Pretty good.
Okay, great. There's the Data Warehouse Toolkit, and there's one of the books
series from the Kimball Group.
Looks like there's another in the chat called, it's a book called Star Schema, The Complete Reference by Christopher Adamson.
That one I'm not familiar with, but sounds like it's the right topic.
I also have another one called Data Modeling Essentials. That's pretty good, following the Kimball model.
Great. In terms of, in my dimensional model, this I guess is not really part of the dimensional model, but it's good things to include when you instantiate it is, create an update date, flagging if it's current. Your ETL processes, if they can generate a unique ID, then you can know what was the process that populated the record, and having an effective begin and end date for slow changing dimensions. This is very important. You want your dimensional model to be stable over time. One of the things I've seen is dimensional models allow you to build incrementally. So you can choose your first subject area, say sales, and I know I need a customer and a date and a product dimension. And then you might say, okay, we're going to model sales quotas. I'll still use date and product. You need to make sure that you model the business, not your data sources. So I have seen some cases where the initial dimensional model, like they just pull the names of the attributes right out of the source system, or they include attributes that are in that system but not in other ones. Factless fact tables. So this is a case where sometimes a fact table may just represent an event that doesn't have any numeric values associated with it. So for example, if you were to model appointments, you might have, who's the visitor, who did they see, those two keys and a date, when did that appointment happen. But you wouldn't have any numeric values associated with that. The degenerate dimensions. So in general, I talked about a fact table should only be dimension keys and numeric values. A lot of people, will put descriptive attributes in their fact tables, and that makes the fact table, it can really increase the size of the fact table. Those descriptive values should be in your dimensions, but there may be times where you have an attribute that is unique to the fact. So for example, if you had a invoice line number, that line number is only going to be on that one particular invoice record. Or if you had an invoice table, the invoice number is going to be 1-to-1 with the fact. So if you had attributes that are 1-to-1 with the rows in your fact table, you might just put those dimensions in the fact table itself. We talked about date dimensions already. Here's a couple of resources on dimensional modeling. I didn't get the Kimball stuff in there. Let me take a note to add the Kimball stuff to that. So that's what I have. I'd be happy to handle any questions, or I may have worn you out.
Scott, I have a question for you. You work as a consultant, is that right?
Yes.
So in your work as a consultant, different businesses, sorry about the dog barking in the background, by the way. How prevalent would you say the dimensional model is in these businesses? And would you say that the use is increasing, decreasing, or holding steady?
I think that the dimensional modeling is holding steady. The change is where it's being implemented. So as I mentioned, it used to be we always did a physical instantiation of the dimensional model, and now we're doing it somewhat less. The other thing is there's types of analysis that are more important to have a dimensional model. So, if you have a report that you just have to run every month, then, having that in a dimensional model, the source data for that report in a dimensional model, because you're going to use it over and over again, or dimensional modeling for not your super analyst, but like your day-to-day analysts, provides them a well-defined area for them to go to. And then it's not, dimensional modeling kind of goes with it, but in every business you need a place where you have your curated data. This is data that's been validated. We know it's good. We know the joins all work. We've cleaned it up. And typically, if you're going to go through all that effort, you might as well do the dimensional modeling. The struggle we always have is dimensional modeling takes some time. And so for your data analysts that are, your super analyst or your data scientist, they're probably not going to want to look at your dimensional model. They want to go look at the raw data. So we have, it's the, data science stuff is added on top of kind of our traditional data warehousing and dimensional modeling, not replacing it.
Thanks.
Hey, this is Jacob. I have a question about slowly changing dimensions.
Sure.
I found that most of the time, if you implement like a type 2 slowly changing dimension, you just implement all the columns as type 2. And I was talking to somebody in more of an academic setting, and they were talking about how you can do the slowly changing dimension type on a column by column basis, particularly if your type 2 slowly changing dimension is very fast growing. In other words, there's just a ton of rows. And one use case I encountered today with a coworker, Aaron, is we have members who they get their account locked out because they forget their password or whatever. And then the row for this type 2 slowly changing dimension changes, but then they get access to their account, so now they're not locked out. And so we're seeing a lot of row growth in a dimension, which the growth in a dimension should plateau, right? Over time, it would probably go fast and then plateau, generally speaking. And so the idea here was you build a type 2 slowly changing dimension, but then certain columns you treat as type 1 columns where you just update every row for that column or something like that. Have you seen that much?
So my experience has been that we introduce the slowly changing dimension concept to a client, and there can be a lot of debate and discussion about, which columns do we want to do with which type of slowly changing. And you can mix them. Like you mentioned, you could do, you could have a table where you implement all three types. One thing that I have found is we used to worry about which columns to track slowly changing versus not, just because of, as you mentioned, the number of rows that might be generated or the effort to do all the columns. And what I found is you go through requirements process and you identify, here's our specific columns where we want to track history. And then 6 months later, somebody says, oh, how about that column that we didn't do it on? So we have moved to the point where our default, if we're doing slowly changing dimensions, we do type 2 and we do it on all the columns in the table. Now, as you mentioned, if there is a column that you don't want to track the history and it is generating a lot of churn, you may decide for that particular column we're not going to do type 2, we'll just do type 1. It's less of an issue now where we've got these, MPP data warehouses like Azure Synapse Analytics or Snowflake, Redshift. You can throw a lot more data into those data warehouses and still get good performance. So the other thing you want to be careful about is a pattern that we're seeing much more common now is to use replication from the source systems into the a landing zone of the data warehouse. And if there's a change in any column in the source record, it's going to generate a new row in your replicate, or a change in the row and flag, hey, I've updated. The column that gets updated may not be a column that's in your dimensional model. So you can end up with like slowly changing type 2 rows where in your dimensional model nothing's changed because, oh, replication detected a change. I'm going to do a type 2 operation and do an update and an insert. So you do have to watch for that you may get non-changed changes. I did put the opening slide in here because it's got the reference for the dimensional, where I'll put the presentation in that example Excel file. They aren't there yet. If you'll give me half an hour, I promise to get those out there.
I saw it open a Google Drive, so I was like, cool.
I have just a couple of questions, Scott.
Yes.
Have you tried doing closer to real-time data warehousing, and then also have you done anything MPP with Azure Data Warehouse?
So, the most real-time I've gotten is like within an hour, refreshing. So, the tools are out there and available. You may need to move from kind of a batch methodology to a streaming methodology to get very close to real time. The couple of things to be aware of is if you're doing analytical reporting, you may not need as real-time information as you assume. So if I'm making strategic decisions, I don't think that what's happened in the last 5 minutes should impact that strategic decision. Now, there may be, like, what do I do next type of questions where you need the real time, and that's what you want to look for. Another thing I have seen is, so there's a prominent application in healthcare. It's called Epic. It's a electronic healthcare record, and then they have their own reporting store called Clarity. And Epic updates Clarity once a day, and I have seen people request that we refresh our data every 4 hours. So you need to make sure that your data refreshes on your analytical system are not more frequent than the refreshes on the source system. Yeah. So those are kind of the things to watch out for. But and the third thing is often, that operational decisions are supported by the business system itself, and you don't need that out of the transaction or your analytical system. So just kind of watch for those things. But yeah, you can get very close to true real time now. John mentioned that the the bit.ly doesn't return anything right now. Yeah, I'm going to need about half an hour just to turn my presentation into a PDF, and then I'll post this up there. So it'll be up there by 5:30 at the latest.
This was awesome. Thank you so much, Scott. We really, really appreciate you presenting and taking all of this time. You know, I just kept seeing people commenting saying, thank you, thank you, thank you. So this was really good. Thank you. Oh, go ahead.
You're welcome. And there's my email address. If you have any additional questions or just want to say hi, feel free to send an email out to me.